In the continuation of our series, The Accurate Revolver, we here at Manny CA are going to run through another tip, technique, tool that you can do to make your revolver more accurate. Very simple, basic hand tools. This time, we're chamfering the forcing cone. But you say, Manny, what the heck does that mean? Okay, remember when we started talking about reaming out our cylinder throats? Yeah. This is from our Lipsy's model 45 Colt 45 ACP, which you guys are pretty familiar with. And what we did was we used our tool, remember our chamfer tool, and we went in here and we opened these up because the guys at Ruger, these are production guns, remember, nothing to badmouth Ruger, but production guns, they go fast and the reamers sometimes wear out, and these holes are not all the same. So what happens is you get a hole that's 0.450, 0.450 and a half, 0.451, 0.451 and a half, whatever. Not good for accuracy. Not good for anything. So what we did was we used a hand reamer and we opened these up to 0.452 and a half. That way our beautifully casted and crafted, I might add, lead bullets drop right through. And we don't have to worry about them getting swaged down. Because remember, the bore is 0.450 or 450 and a half, technically. We've slugged this one's at 450. Look back in our playlist, we'll show you how to slug your bore to find out. Basically, a revolver is like a funnel. You're going from the big mouth right here, which is where you plug your ammo in, to a progressively smaller to where it comes out. Gradation. And what happens if this is small or smaller than your bore? You're going to get your bullet bouncing around in here until it comes out. So we reamed our cylinder. One more thing we did was we checked for bore constriction right here with the thread. They call it thread constriction. And what happens is when they spin these on, right, sometimes it gets a little tight in here and you'll get it where you have a tight spot. That's not good for accuracy either. So you can open up your cylinder throats and you can chamfer your forcing cone like we're going to do today, and you will still have bad accuracy. If that happens, there's something wrong with your bore, or you're going to have to lap the constriction out. That's another video, folks. So what exactly does a forcing cone do? Allow me to elucidate, if I may. The forcing cone is like a bridge, and what it does is it connects your throat from the cylinder to the barrel right in here. And what this does is as the bullet enters the forcing cone, the bullet will actually shift your cylinder half a thousandths, maybe a thousandths, up, down, left, right, just to center it in the bore. A centered bullet is a more accurate bullet. It's all the way it hits this ramp. And that's what basically this is. This is like a funnel. It's a ramp. When they put these on at the factory, they screw this in up into the shroud. That's this area right here. And then what happens is, if this is sticking out too much, they come and they take a cutter and they go bzzz, and they trim that down. That way you have the correct gap. Remember cylinder gap? Yeah, that's the space between the throat and the forcing cone. Well, whatever forcing cone they've made, they just shortened it or they got rid of it when they trim this down. So what happens? You have little to sometimes non-existent forcing cones. Different manufacturers use different degrees. That's right, degrees. We're gonna get a little technical here. Ruger likes to use what's called a 5-degree chamfer in here. Smith & Wesson uses 8 degrees. And 11 degrees is probably the most optimal when you're using lead bullets. Think of it as a ramp. Remember when you were a little kid? Exactly. So if the ramp is too steep, guess what? Bullet kind of gets shoved in there and it all goes haywire. But if you've got a gradual taper, you're going to have better accuracy. That's right. So if you like shooting cast bullets, then you're going to want to go with a 11-degree chamfering cone, which is what we've got right here. And you can find these online. You can see what it looks like. Let's get a close-up. Yeah. Ooh. Let's get a nice close-up. There you go. So you can see what the tool looks like. That's 11 degrees. The kit comes standard with a bar, which you see right here, and a handle, T-handle, or center guide, and what they call breaker bars. And what we're gonna do is go in and we're gonna recut the forcing cone. Don't be scared. It's not that difficult. Trust me. If it was, I wouldn't have shown it to you. And you're asking, but Manny, what the heck is this gonna do for my accuracy? The very purpose of a Revolver's forcing cone is to deliver the bullet from the cylinder throats to the bore with minimum bullet distortion. As we said before, when a bullet starts moving out of the cylinder throat and the nose of the bullet contacts the forcing cone, this is when the cylinder is going to move a few thousandths up and down, left and right, until the cone brings the cylinder throat into alignment. If cylinder to bore alignment was perfect for every throat, you wouldn't need a forcing cone after all. However, factory produced revolvers are never perfect. The other purpose of the forcing cone is to act like a sizing die. It changes the shape of the bullet so it fit in the bore with a tight seal. On a plus side, lead bullets will actually form to the bore diameter easier, which would lead usually less wear and tear on your bore. So you could shoot a heck of a lot more cast bullets than say jacketed bullets. Some of the worst bullets are semi-wad cutters or the full wad cutters, where the nose is almost non-existent and it doesn't contact the forcing cone after all. It's not until the full diameter of the bullet strikes the cone, and by that time, it's kind of too late. And so what happens is your bullet will enter the forcing cone kind of skewed. And from there, it's just all downhill because it'll enter your bore the same way and magnify that by 20 yards, 25 yards, 100 yards, however far you're shooting. Ruger factory cones are 5 degrees. Smith & Wesson's are 8 degrees. The angle is the total of both sides. So a Ruger cone will be 2.5 degrees per side. Something to keep in mind. Now what happens is when we bring this cone to be cut, we're not gonna cut too much and we're gonna go slow. Quick note on the reamers. They're very sharp and will cut way too deep unless you use a little bit of pressure. Any kind of oil will do, and that'll keep it from chattering. Once the cone has been cut properly, you'll see a fresh cut from the barrel face to the lands. Do not cut any deeper than necessary and finish the job. Do not cut part ways. That's called a compound cut, and that's going to distort your bullets. A few other things to think about before we start doing this. Don't try to measure your forcing cone. I've never really been able to use the tools that they've got to do that correctly. Easiest way to do is to take a Sharpie and run a Sharpie on the inside of your forcing cone. Set up your cutter like so and do a couple of light passes. Remove the reamer and you'll see if you've removed any or all of your Sharpie. If you've removed some and it looks like it removed it even, chances are your cone is already chamfered. Before you start, we're going to give it a little bit of spray here. I like WD-40. It's easy. It flows. You don't need a lot, but you do need a little. You're going to pull it into the forcing cone. Now we're set and we're ready to go. Our die is seated firmly into the forcing cone. We've got our centering bit right here in the front. And the most important thing, we need to turn clockwise. Clockwise, people. So we're gonna hold, give it a little bit of bracing right here in the front and give it a turn. And ooh, you can feel it cutting. I don't know if you can hear it too. Yeah. We do a couple of turns. We'll stop. Yeah, you can see the shavings on the end. See that? Oh, we're getting some cutting done. Stop periodically. And this is what the breaker bar is for. And take a look. Go slow. And let's see if we can see anything. Oh yeah, look at that. You can see the cut that we did. Oh man. And you can see right there how that forcing cone is maybe halfway, I don't know if it's picking it up, but it's about halfway cut, and you can see the fresh cut. You can also see a little bit of leading that was caused by the crappy miscut forcing cone to begin with. We're going to continue cutting, going slow, and checking. We want that line to come all the way up to contact the lands and the grooves. Oh, by the way, this is where you don't want to stop. A great representation of what's known as a compound cut. You've got two cuts, probably the 5 degrees right there on the left side, meeting up with the 11 degree that we just cut. A compound cut will give you crappy accuracy and a lot of really bad leading. This is one of those things where you just can't rush. We're going to clear off our cutter of any shavings that we've got on there and take a couple more turns. And our second pass, you can see we've got more shavings. Oh man, now you can really see how nice and shiny that fresh cut is. Look at that. Oh, that is like a thing of beauty. I can't wait to bring this guy out and shoot him. You could really see that fresh cut. Give us a little bit more light, very light pressure. I'm just kind of buffing her. I want to buff it now. I'm just buffing it. Remove your tool. Don't forget, you want to clean out any shavings by not driving them into the bore, by pushing them out this way. Now be aware that when you do something like this, you will lose about 50 to 75 feet per second in velocity when it comes to regular jacketed bullets. But I think it's a good trade-off depending on the kind of accuracy you're going to gain with your cast bullets. And if you're a cast bullet fanatic, such as we are over here at the channel, it's really worth the trade-off. Here's another angle. You can really see the cut, the fresh cut that we made, and how the fresh cut went from the beginning of the forcing cone all the way down to where the lands, there we go, where the lands and the grooves of the rifling started. This cut is now cut at 11 degrees. This should remove a lot of leading and a lot of issues for you guys shooting lead bullets. Did you see how easy that was? That was spectacularly easy. You can do this. You do not need to pay a gunsmith or an Uber gunsmith to do something like this. It's fun, and it's something that anybody can do. If you guys have any qualms, if you are not mechanically inclined, then don't do it. Pay somebody to do it for you. There's a lot of guys out there that can do it. But if you gotta, go in with a couple of guys, buy the tooling, pass it around, do it yourself. You only gotta do it once. You have any questions, comments, or concerns, send them on down. We'll see you guys on the field. Until next time.
Giovane, giova te, giova tutti quelli che ci vogliono stare dentro, alla periferia di nessun centro. Giovane